All right, let's take a look at flowcharts and pseudocode and discuss what they are and how they would help us in programming. Specific here to MATLAB, but in general, flowcharts and pseudocode, that these concepts are applicable across all programming languages are actually key to coming up with a very good and efficient, robust program. Okay, and why do we want to discuss these? Because so far today, most of the programming we've been doing have been pretty simple, just some computations, very direct, very simple computations. But when you get into more complex code and problems, you want to come up with more complex algorithms, if you will, or sophisticated algorithms. That's when using using flowcharts and pseudocode will help you in brainstorming and coming up with how you want to design your code. Okay, so flowcharts, as you see here, they're going to be a graphical approach. So if you're a visual person, this is how you would present your code to a potential audience. And then pseudocode is a verbal description of what your code is supposed to be doing. Okay, so let's start with the pseudocode. And pseudocode is actually very useful, especially when you're new to the programming language. Again, no matter what programming language you're doing, if you're still trying to learn the syntax, knowing your thought process, which is essentially the pseudocode, it's going to be how you want to approach that problem. So you write it down, and in our case, it's going to be for instance, the comments. Okay, so if we're going to be commenting, that's why I mentioned that whenever you write code, you want to make sure you comment it pretty in a good amount of detail so that you can understand what you're trying to do. When you get into the habit of commenting your code, it makes it easier for you to follow that logic that you're trying to approach that problem. Okay, so as described here, it's going to be an outline to set of statements to solve that problem that you're trying to do, or describe the problem statement and then try to taking steps to solve it. And then essentially what you take those comments or those verbal description, and you make them into comments in your code. Okay, and then under each one of those comments, that's when you start inputting the proper syntax of code that you want to solve. Okay, so let's look at an example here. Let's look at this example. And this is a pseudocode example. You've been asked to create a program to convert miles. So you want to convert miles per hour to feet per second. So that's your problem statement. Okay, and you're specifically told the output should be a table. So now you need to create a table, complete with a title and column heading. So you want to have title and column headings. Okay, so this is your problem statement. So now you can use this description to extract your verbal description of how you're going to approach this problem. Okay, so the main computation here you see is going to be this conversion factor of miles per hour to feet per second. So if you don't remember the conversion of miles to feet, 5,280 feet per mile, of course hours to second, you can always look it up. Okay, so this is our problem, and we want to solve this based upon what we know. Okay, so this is how we're going to approach this. We're going to define a vector. Okay, and this is going to be our input vector of miles per hour values. Then we're going to do the computation, which is converting this miles per hour to feet per second. And then we're going to combine our input, our miles per hour, and our feet per second. Okay, so let's go ahead and do this here. This is going to be our input. This is going to be our output. Okay, and we're going to combine them into a matrix. Then we're going to create a table, title, create column headings, and then finally display the table. So essentially what this all is, so this whole step here is our pseudo, if I write it properly, pseudo code. Okay, so that's essentially what pseudocode is describing the steps you're going to take to solve the problem. Now remember, we don't know the syntax yet, and again, you can apply this to any programming language, but the idea of coming up with that thought process will greatly enhance your code efficiency and robustness, as well as understanding and learning the syntax of that programming language. Okay, so in MATLAB, we're just going to take everything we just wrote and put it in under comments, and remember the % here is going to be your comment. Okay, so we just inserted that in there. And then after we do that, we're going to define our inputs. So we define our vector, and this is arbitrary, so we're just going to say our vector miles per hour. We're naming it mph, going from 0 to 100 miles per hour in increments of 10. You can choose whatever you'd like, and then we're going to, this is the key here, is our conversion factor. So we're saying we're naming our feet per second as fps. And then we're just saying, okay, we're going to input the miles per hour, multiply it by 5,280 feet, divide by 3,600 to get to the seconds, okay, from the hours. And then we're just going to put them into a table. That's the syntax to just putting them into a matrix, if you will. Creating a table, we can use the display function here. And then we're just giving it a title. And then we're doing the display function again, making some spacing just to make it look a little neater, giving the first column mph a header, and giving the feet per second as feet per second header. And then we're going to take the fprintf function and pointing back to the table up here, and because the table we have two columns, if you will, or variables. We got miles per hour, feet per second. So now we have to define the formatting for two different arrays. So we have, remember the format, you start with a %. 8 is the number of spaces you're going to be using, allocating, and then after the decimal point, you're going to say how many significant figures you want. This is, in this case, we're just saying 0, and then f is defining it as a floating point number. And then for the second part, feet per second, we're doing the same thing, 8 spaces, dot 2 to give us 2 significant figures, and we're going to do f for floating point. And remember to use the return carriage sign, if you will, the \n, that gives us, takes us to a new line. Okay, so as we do that, now if we execute this code, it's going to give us a table. Okay, before we show you the output of that, let's jump into flowcharting. Okay, and flowcharting is taking that pseudocode, if you will, along with the potential syntax, depending how you want to go about it, and putting it in a visual fashion. Okay, and that's actually for some people actually is a lot easier than actually writing that pseudocode. But again, the purpose is you want to present an overview of your code or your algorithm to a potential audience, and then from there you can convert it to pseudocode. So that's one layer above writing more specific details. So let me show you some rules when you're doing flowcharting. Okay, so some simple rules and simple symbols that you have to follow when you're doing flowcharting. You have this oval, you have a parallelogram, you have a diamond, and you have a rectangle, and all these stand for something when you are coming up with a flowchart, and you just have to remember these. Okay, and it's used commonly across not just programming but engineering disciplines and other disciplines to come up with flowcharts to visually present what you want to do. Okay, so an oval here is going to indicate the beginning and the end of a section. So before you start your code, you can just say start, and then when you're done with your code, you say end. So you put this is going to be the beginning of the section. Okay, and then also you can put it at the end. Okay, your parallelogram is going to indicate whether you're going to have inputs or outputs. Okay, inputs or outputs. Your diamond is going to be your selection structures and your repetition structures. Okay, so it's going to be a decision point based on what we discussed previously, a conditional statement. If this is less than that while this is happening, then you take a decision, and that decision is going to be either go one direction or go another direction based on that decision. Okay, and then your rectangle is just going to be some computations you're going to be doing. Okay, so computations or calculations that you want to do. So using this knowledge, then you can build a flowchart. Okay, for the sake of the example we just gave, there weren't any converting from miles per hour to feet per second. There weren't any selection structures, there weren't any repetition structures, so it's pretty straightforward, meaning you're not going to have any diamonds in there, but you will have, parallelogram and a rectangle. Okay, so in this case, if you were going to convert that pseudocode, into a flowchart, you simply have your start. You take that pseudocode, you write it in here, just like you did in the comments. You want to define a vector of miles per hour. You want to calculate this. You want to combine into a table, and then you want to create an output table using display fprintf. Now, if you're going to ask the user to input a potential vector, then the top here, this rectangle, could potentially be a parallelogram. So there's some flexibility here based on how you decide to write your code. Okay, so that's the simple introduction of using pseudocode and flowcharts to come up with a presentation and to an approach to writing more complicated code. Again, this one isn't very complex, it's just pretty straightforward, but I wanted to share that with you here. And next we'll talk about logical functions.